Welcome back to my office. What we're going to do today is go through a little bit more about designing studies. And so I have a little study here set up. And again, reminder, if we have, let's pick a nice easy number here to work with, 300 patients. So in this case, again, what's the word that we call these things that we're doing all of our testing on? Put that in the reflection response. So we take those and we randomly assign them. And I use some process. So for example, if I want to take the rand_int function on my calculator, I would number everybody. 0, 0, 1 through 300. And the reason why I do 0, 0, 1 is 300 is a 3-digit number. So if I'm going to be doing random selection, I need all of my possible people to be a 3-digit number that I can select. So if I were doing this on my calculator, I would do rand_int 1 to 300. Now, granted, I'm going to number them all 0, 0, 1 to 300, but my calculator only needs to do 1 to 300. This is for my purposes, all right? And when doing an assessment, I need to indicate this clearly, that I label them 0, 0, 1 to 300. Rand_int 1 to 300, and then I'm going to just start selecting them. So I'm going to select all three without replacement, 300, without replacement. Without replacement means once they're in, they're in. You know, it may be the first 100 go to chemo, the second one get cranial radiation only, and the last ones get chemo and radiation. All right, so what I have going on here is I have 3 different treatments. These 3 different treatments has, the options are chemo, radiation, so this would be for cancer treatment, and both. Okay, so I have 2 different factors. Chemo and cranial radiation are my 2 different factors that I need to take into consideration. So I have 2 different factors making up my 3 treatments. All right, I randomly assign them. I do my data collection. You know, I give them all what they're going to get, and then I compare results at the end. All right. There's 3 aspects that go into doing a well-designed study. Randomization, which I did with the random assigning. Okay. Replication, and this has 2 aspects to it. Replication. First aspect is I have 100 people here in each of these treatments. With 100 in each of those treatments, it's going to be repeated 100 times each, so replication. The other aspect of replication is, did I do my whole process in such a clear way so as someone else could come back and redo my entire study exactly as I did it to verify the results? All right, and that's very, very important in medical studies and a lot of other studies that it's replicable. All right, and then last thing is control. And again, control has, when I talk control here, I'm talking people did not get to choose which category they're in, okay? If they got to choose what group they go to, then my experiment lacks control, all right? So I use a random assigning process to control which group they go to. I control how many treatments there are, within the concept, or within how many people there are. Remember, you're in the reflection response telling me we don't call them people, we call these things something, right? And then in this case, there were 3 treatments, but a good study has all 3 of these, all right? Randomization, replication, and control. Another type of study we can do is what's called a matched pairs. Now, a matched pairs still uses randomization, replication, and control, but what I usually do is, I don't want to do that. I'm going to take, let's see, 2 treatments. Yeah, let's do that. Or I should say 1 treatment. So let's think about a car. So if you ever go to the get your oil changed, or you go to the car parts store, you can see these things called fuel additives. And they say on the little package that fuel additives help your engine to run more efficiently, which means theoretically you get better gas mileage. All right, so matched pairs is I'm going to take a car, and under normal conditions, I'm going to drive the car, same car, all right, so car 1, and here we're going to have car 2, and here we're going to have car 3, etc., for replication purposes. And the car 1 is going to be driven under normal conditions without the additive. And then we're going to do the same exact normal conditions, just a normal work week, but with the additive. And then we're going to compare those results. And we do the same thing for car 2, and we compare the results from car 2. So overall, if we're talking about gas mileage, I got too many A's in there, mileage. If it's normal without gas mileage and then normal with, and if I go without, and here's what you need to decide. If I go without minus with, all right, if the fuel additive is doing what it says it should do, which is reduce gas mileage, or sorry, make your gas mileage better. So instead of getting 30 miles per gallon, maybe you get 32 miles per gallon. All right. Without, it's 30. With is 32. So if the gas thing is doing what it's supposed to do, these should be negative numbers. So we're desiring a negative value. A lot of times you get to choose which one you're going to go, which one minus which. If you're ever given a choice, make sure you write down what you're doing. Can't assume that I know what you're doing. The nice advantage of doing a matched pairs is, didn't circle that very well. I'm comparing how the fuel additive does in each car. All right. So my car is my independent variable, and then I'm comparing the results within that. And that you can do the same thing when doing any type of a design with people as well. So let's say we're doing people. But what you need to be careful of then is, instead of you do one first and then the other one second, you would have to randomly decide, car 2 or car 2, so this would be person 2. Person 2. They do A then B. And maybe you randomly assign, and person 3 does B then A. All right, so in that case, you'd have to randomly assign which one they get when. Obviously not a fuel additive, maybe it's a taste test. So that one outcome isn't going to influence the other outcome. So if there is a difference, we should see it either way, whether it's AB or BA. And then control also means, in some cases, like when we're working with people, maybe I have person 4 who gets B, so no change. All right, that would be considered a placebo. And this would be my control group. All right, my control group is, they technically got no treatment at all. They only got B, so whatever they're going to guess. So if it's a taste test, we're going to assume that anybody that gets BB has a 50% chance of just guessing. All right, so we're looking for these others to be something greater than 50% or less than 50%. But that's how a matched pairs works. We've already talked about blind and double-blind experiments. And then the last thing is realism. The last thing is realism. Realism just means, you can do a lot of studies, but is it really mimicking something that we care about in reality? Like real life, is it something that's necessary to do? All right. Hopefully, yes, but you're going to find out if you do any kind of work that there are an enormous amount of money spent on very unrealistic experiments. It's possible that they could result in something significant, but that's a question for realism. Like, is this something we're really going to do? And then the last thing, sorry, I said this was the last thing, statistical significance, which is another name for, hey, we did this test. Significance. And we found out that, yes, this is statistically significant, that there is a difference between the 3 different cancer treatments. All right. Is that practically important? In this case, the answer is yes, because it's going to impact how, people's lives and how well they go through treatment and things. But it's possible that there is a statistical significance between those who like tap water versus bottled water. Is that practically important? For most people, the answer is no, but for some it might be. But what I'm getting at here is, just because something is statistically significant, maybe it's like really, really, really significant that what we saw happened, but in terms of practical importance, they're not synonymous. Just because it's one doesn't mean it's the other. So you got to be careful that we're eventually going to say, wow, this is statistically significant. It could have happened, less than 0.1% of the time. And which means that the actual outcome that we're seeing is very significant. There's a huge difference between the two. Does that mean it's practically important? Not at all. Just because something is a low probability of happening by chance, that doesn't, but then it actually does happen. You're like, oh, it shouldn't happen, but it did. Wow, that's really significant. That doesn't make it practically important. These videos are meant as a means to get the information. Then in class, so you're going to watch the videos. We're going to do the problems in class. And generally speaking, you're going to hear me say that I don't really want you doing much more than 15 minutes of work outside of class for this. So in watching the videos, typically, they're going to be less than 15 minutes or less, and then you fill out the reflection response form. This does not take into account studying. And you all know how much studying you need to do. But when I say studying, I mean active. All right. It's one thing to look back at past problems, but it's a better thing to redo past problems. It's one thing to read, but then it's better to synthesize. So after you're done reading, so don't take notes while you read. Synthesize, I'm spelling it wrong, I'm sure. After you're done reading, then go back and write a summary of what you wrote, of what you read. The same thing goes true for watching the videos. Watch the video and then go back and do a summary. You're trying to pull together those ideas. At the end of every chapter, there is a summary that you can also read. But my recommendation is compare that to the summary that you wrote. See how close you are getting to doing those things. And this is another way that you can remember some of those terms, prep yourself for tests and exams, but also look at the examples in the book. The book's examples are there for a reason. They've been put in that book because they've gone through and they've been tested to show that they're actually good problems to do and prep you for the problems in the back, or problems in each section. There's my quick little study tip. I've got more. If you want to ask, I'll let you know. Hopefully that helps you in the process of prepping for my tests and the AP exam at the end. We'll see you in class.